Why CPU scheduling matters? CPU scheduling is one of the most critical functions of an operating system, determining which process executes first and how CPU resources are allocated among competing tasks. Traditional scheduling algorithms primarily focus performance metrics such as waiting time, turnaround time, and response time. However, modern computing systems face an additional challenge: energy consumption. Today, power efficiency has become a major concern across laptops, mobiles, devices, cloud servers, and large-scale data centers. The problem we are addressing: excessive CPU usage. Traditional algorithms may keep CPU running at full capacity unnecessarily, wasting power. High energy consumption. Process executing without energy consideration drain batteries faster. Overheating issues. Prolonged high CPU usage generates excess heat, reducing device lifespan. Reduced battery life. Mobile and embedded suffer from short operational periods. Our project introduces an energy efficient approach where scheduling decisions consider both performance and energy usage. Project objectives: implement multiple scheduling algorithms, FCFS, SJF, priority and round robin scheduling. Second, calculate scheduling parameters: completion time, waiting time, turnaround time, response time. Third, measure energy consumption. Track power usage of each process during execution. Generate Gantt charts, visual representation of process execution order. Fifth, improve CPU efficiency. Balance performance with reduced power usage.
Now I will talk about methodology. First one is process input. It provides like process details, algorithm selection in which we choose scheduling method, like which scheduling we have to choose, like FCFS, round robin, SJS, and extra. And process execution, it runs according to the logic, and then parameter calculation, computes metrics and useful for calculations. Energy management, that tracks power usage, that how many watts energy is consumed while running the algorithm. Result display, it shows analysis and how we can implement scheduling algorithm implemented. Like first one is first come first serve. In this algorithm, the processes arrives first and executes, following a simple queue-based approach. Second one is shortest job first, SJF, in which we first keep in mind about execution time, like the which have first executes first, which have low execute execution time. That we call burst time for optimizing waiting time. Third one is priority scheduling. Processes executes according to assigned priority levels with higher priority processes running first. And the last one, round robin. Each process receives a fixed time quantum before being preempted and moved to the back of the queue. And our energy consumption model. First, how we calculate energy. The formula given is energy is equal to burst time into time in energy rate. This allows us to analyze how power each process consumes during execution and make informed decisions. Energy aware scheduling. By incorporating energy calculation into scheduling decisions, our algorithm can prioritize processes that consumes less power while maintaining acceptable performance level. Gantt charts. Venkatesh, now you start.
Yeah, now change the slide. Advantages and applications.
You have to speak from Gantt charts and
Okay, coming to Gantt charts. Completion time CT and turnaround time TAT, waiting time and response time. Then coming to advantages and applications. All algorithm prioritize efficiency and longevity by reducing energy consumption and maximizing CPU utilization. We have created a system that handles multiple scheduling types while remaining easy to analyze. The impact is immediate for mobiles and embedded devices where battery life is critical, as well as data centers and cloud environments. And to wrap up, we successfully bridged the gap between performance and power saving. This project sharpens, one second, yeah, this project sharpens our skills algorithm implementation, like integrating AI for predictive scheduling, enabling real-time monitoring for instant adjustments, developing a GUI, and expanding into distributed cloud system. Thank you.
Up, now we'll explain code. Here is our code. We used CPP language for our code, and IO stream is used for it is header for input and output. Vector is used to create dynamic arrays. Queue is used for queue database structures, and algorithm for sorting, like give access to sort, and IO manip is used for formatting and using nameplace std so that we can directly print out the statement. Here we have taken inputs for arrival time, bus time, completion time, turnaround time, waiting time, and response time. We also initialized priority and remaining bus time. For energy rate, we use double function energy use for the boost completion. For colors like green, sort process according to arrival time. It returns true if A arrives before B. Now for displaying function, we used word display vector process P. We initialized to 0, stores average of waiting time, turnaround time, response time, and total energy. Use table heading. This one is used for table heading, and then column names. Aligns output to the left side, sets column width. Column width is 8. Loop through every process will run. For resulting, this is for printing average waiting time, average turnaround time, average response time, total energy use. Like this one is used for printing our Gantt chart, will print in yellow color for processing average calculus. सुन रहे हो उदित, तू कोड एक्सप्लेन करेगा या मैं पूरा करूँ?
कर दे अब तो।
You will when
अरे वो कर दे, फटाफट खत्म कर दे और फिर रन करके दिखा दे।
function we will print FCFS scheduling, SJF scheduling, priority scheduling, and all of them. We have to choose like which process we have to select, like FCFS, SJF, and all. And choice. Or we use choice function so that we can select which process we have to select. This one is for our code. We use if else for like choosing which process. This code is used for print Gantt chart completes. ठीक है, हो गया, इतना ही था इसमें. Now we will run the program. It will ask us which process we have to select. Like I will select first one. It will ask us how many process we have, number of process we have to input. Let's say 3. For process 1 arrival time, let's say 2, and bus time is 3. Energy consumption rate, let's say we take 8 megawatts. Process time is arrival is let's take 4 and bus time is 5, energy consumption rate 9. For third process we take arrival time 6, bus time 7, energy consumption rate let's say 10. It will give us Gantt chart and final table. In our process, average waiting time is to be calculated as 1.667, average turnaround time 6.667, average response time is same as waiting time, and the total energy consumed is 139 megawatts. Last code FCFS calculation. ठीक है